Okay, today we're going to be talking about while loops. And up until this point in time, all of the code that we've written has been sequential, meaning when a method is executed, the computer begins at the first line of code in the method and it sequentially executes the code until the method is done. And then it returns back to wherever, I guess execution returns back to where it came from. Okay, so all of the code that we've written so far has always been top to bottom sequentially executed. Sometimes, however, you want to execute a piece of code multiple times, and you want to do that without having to copy and paste, which I think one of the themes so far in this course is that that's usually a bad idea. Okay, so that's where this idea of loops comes in, and the very first loop we're going to look at is the while loop. So what do loops let you do? As I said, they let you execute your code multiple times. In Java, there are three types of loops. There are while loops, there are for loops, and for each loops. We're going to begin by talking about while loops, and then we're going to look at for loops. The for each loop we will not talk about in class, but it is in your textbook, and you can read about that and see examples of how to use the for each loop. Now, a little caution, not really a caution, we're going to look at while loops first, which means that you are going to want to use while loops always. And when we learn about for loops, you're going to have a tendency to still want to kind of shove everything down into a while loop because it's the first loop you learned about. If we had learned about for loops first, it would be flipped. Your tendency would be to always use for loops. But when we move to for loops, we're going to see that there are different uses for while loops and for loops. And you're going to have to untrain your mind or retrain your mind to use for loops when appropriate and to really combat that tendency to use a while loop. Okay, so I'll say that now, I'll say it again, and just give you forewarning. Okay, what is a while loop? Here is the syntax for a while loop. Super, super simple. Okay, so we have a new keyword, the while keyword, and then we have some Boolean expression. If that a Boolean expression evaluates to true, then we enter the while loop and we execute the code found inside. Now, up to this point in time, this seems very similar to an if statement. The difference happens at this closing curly bracket here. Okay, so an if statement, when we hit that closing curly bracket, we sequentially, or the computer continues on sequentially executing code. With a while loop though, right, the flow of execution jumps back up to the while loop. Okay, so we would say while, evaluate the Boolean expression. If it's true, execute the code inside and then go back up and re-evaluate the Boolean expression. If it's still true, we will execute the code inside and go back up. While, right, as long as that Boolean expression is true, we will continue to execute the code inside the while loop and go back up. At some point, hopefully, the Boolean expression evaluates to false, at which point we finish the while loop and continue on. Okay, so really the biggest difference is right here at this closing curly bracket. An if statement simply keeps going. The while loop, though, goes back up. Okay, so here's our first example of actually using a while loop. So here's a static method called sum. The idea is that you pass in an integer, and this is going to compute the sum from 1, 2, 3, 4, 5, 6, all the way up to n, which is whatever number you passed in. And so for example, if n is 4, and we'll run through this example, this method should add, it should sum 1 plus 2 plus 3 plus 4. Okay, so 1 plus 2 is 3, and then 3 plus 3 is 6, and 6 plus 4 is 10. So let's see, 1 plus 2 plus 3 plus 4. So if we were to call this method and we were to pass in 4, so n equals 4, this is what we want to be computed. What's the sum of the first n integers? In this case, what's the sum of the first 4 integers? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that's the answer that should be returned. Okay, looking inside, I have two local variables here. We have int sum equals 0. That's going to hold our answer for us, and I'm initializing that to 0. And then int cur equals 1. Cur is going to keep track of where we are in this summation here. So we'll start out with 1 and we'll add that in. And then we will move to 2 and we'll add that in. And then we'll move to 3 and we'll add that in. Right, so we have this running tally that we're keeping, and cur is keeping track of where are we. Okay, in this summation, how far have we gotten so far? Okay, so cur starts out at 1 because we want to begin at the beginning. And while cur is less than or equal to n, okay, so cur should be 1, 2, 3, and 4. So cur is starting at 1 and it's going all the way up to n. Okay, so while cur is less than or equal to n, sum equals sum plus cur. So take the current number, add it into our running sum, and then we're going to advance cur. And here I have cur plus plus. The plus plus operator is a shortcut for cur equals cur plus 1. So if you want to simply increment the value of a variable by 1, you can explicitly do that by writing cur equals cur plus 1, or because that becomes really cumbersome and having to type that, it just kind of gets annoying, you can say cur plus plus, and that's a pretty convenient shortcut. Okay, once we increment cur, right, we jump back up, right, and then we check, is cur less than or equal to n? If it is, right, we enter in here again, we add the current value into our sum, and then we increment cur. At some point, because we're incrementing cur, but we're not incrementing n, at some point, right, this is going to be false. And so at that point, we know we've finished tallying and we'll return back the answer. Okay, so this is how we would use a while loop to sum the first n integers. Okay, let's actually step through this. So once you start writing code that has loops in it, your code becomes much more complicated because although it's only like 3 lines of code, when we actually run it, these 3 lines are going to unroll into however many iterations we need the while loop to do. Okay, so when you're trying to debug code that has a while loop or a for loop, it's really good to get a sheet of paper and just unroll the entire loop and step through it explicitly and convince yourself that there's no bugs and it's doing what it should do. Okay, and we're going to see an example of that right now. Okay, so what do I mean by unrolling the loop? I mean, we're going to step through every iteration and we're going to write down the value of every variable and we're going to update it as the while loop updates it. And at the end, we'll see what our answer is. And hopefully this code is correct and there's no bugs in it. Okay, so let's assume that we call this method with n equals 4. So this is going to be our starting value. The very first line of code is creating a local variable sum. Oops. Okay, we've initialized that to 0. Then we have another local variable cur. We're going to initialize that to 1. And we have our very first Boolean check. So is cur, which holds the value of 1, less than or equal to n, which holds the value of 4. Okay, so this is the question that is being asked. Is 1 less than or equal to 4? And the answer is yes. Okay, because this is true, we're going to go inside the for loop. I like to indent just to show that I'm inside some other context. Here we're inside the while loop. So the first line says sum equals sum plus cur. In this case, sum has a value of 0. Cur has a value of 1. So the variable sum now holds the value 1. Next, we're going to increment cur, so cur plus plus. Okay, cur now has a value of 2. Okay, we've hit the closing curly bracket of our while loop. We're going to go back up and we're going to reevaluate this Boolean expression. So is cur, which now holds the value of 2, less than or equal to n, which is still 4. Okay, so is 2 less than or equal to 4? Yes, it is. Okay, so we're going to go back inside the while loop. And sum equals sum plus cur. Now, in this case, sum has a value of 1. Cur holds a value of 2. So sum now has the value of 3. Next, we're going to increment cur. So cur equals 3. And then we hit the bottom, the closing bracket on our while loop, and we go back up. Okay, reevaluating the Boolean expression again, right, is 3 less than or equal to 4? Yes, it is. We go inside, right? Sum equals 3 plus 3, which is 6. Cur is incremented. It is now 4. We hit the closing curly bracket and go back up. Okay, is 4 less than or equal to 4? Yes, it is. Okay, sum equals 6 plus 4, which is 10. And cur equals 5. Now, this is kind of an important point because you as the human being, at this moment in time, you know we are done with the while loop, right? Cur is now 5. That's past what we're interested in. In your human brain, you know we're done. The computer does not know that we're done. So the computer, once it increments cur to 5, it does not skip the while loop and keep moving at all. So at this point, cur is 5. We would hit this closing curly bracket, go all the way back up, and we do one last evaluation. Is 5 less than or equal to 4? It's at that point that the Boolean expression evaluates to false, and then and only then does execution resume after the while loop. I say that because sometimes students assume that if you're in the middle of the while loop and something changes, so the value of some variable is updated, and you, the human, you know, okay, we're done. Oftentimes students assume that the computer knows that as well, and that the computer will then jump out of the while loop and resume execution, and that's not true. It always has to go back up, reevaluate the Boolean expression, and it's only when that's false that it resumes execution. Okay, so here's what I meant by unrolling the while loop, and I highly recommend as you write more code or more complicated code involving loops, if you want to convince yourself that your code is correct, or you know there's a bug and you're trying to track it down, I highly recommend a sheet of paper, a pencil, and some patience. Unroll the loop, do everything that the code is doing until you track down where your error is. And it requires patience because at some point you kind of get annoyed. You're like, oh, come on. And it's easy to just skip ahead, and then it wasn't a very useful exercise. Okay, so going back to that initial summation that we want to compute, 1 plus 2 plus 3, plus 3 plus 4, basically what we've done is we've taken the summation and we've broken it into the iterations of our while loop. Okay, so we started out with our sum being 0, and then the first iteration of our while loop, we added in 1 to that sum. The next iteration of the while loop, we added in 2. The next iteration, we added in 3. The next iteration, we added in 4. And then the next iteration, we recognized we're done and we quit. Okay, so anytime you have a summation, anytime you have something that you want to like add a bunch of things, multiply a bunch of things, you're doing the same repetitive task again and again. You can think about how could I decompose this or break this down into some sort of loop, in this case, a while loop. We could also have done this backwards. So there's no reason why we had to sum 1 plus 2 plus 3 plus 4. We could have just as easily summed 4 plus 3 plus 2 plus 1. So we could have counted down instead of counting up. Okay, so here's an example of what that code would look like. So there's a few things that would change. Here we're going to start our local variable cur at n. So we're going to start at the end now and work our way down. Also, our Boolean expression changes. So if we wanted to sum 1 plus 2 plus 3 plus 4, we're going to start cur here at the end, and we're going to keep going until at some point cur is going to reach 0, and then we know we're done. Okay, so my Boolean expression now reads, while cur is strictly greater than 0, here, this line of code is exactly the same. We're going to take the value of cur and we're going to fold it into our running tally. And now this has changed. Instead of cur plus plus, we're going to do cur minus minus. Again, the minus minus operator is simply a shortcut for saying cur equals cur minus 1. After a while, particularly with loops you tend to increment and decrement so often, it becomes kind of annoying to have to write it. And so the minus minus operator is just a shortcut. Okay? So I'm showing in red here the 3 things that would have to change: our starting spot, our initial value changes, our Boolean expression changes, and how we're advancing. Instead of moving up, we're now moving down. Okay? Other than that, everything is just the same. Okay, so let's step through this code and convince ourselves that it is in fact true and that we didn't mess up anything in making these changes. Okay, so again, n is 4. Sum starts out as 0. Here, cur is going to start out at 4. And our very first Boolean check is asking, is 4 strictly greater than 0? Yes, it is. So we'll go inside. Sum now will equal sum, which is 0, plus cur, which is 4. And then we're going to decrement cur. All right, we go back up. Is 3 strictly greater than 0? Yes, it is. So we go inside. Sum equals sum, which is 4, plus cur, which is 3. And so that gives us 7, and cur is decremented to 2. Okay, we hit the closing curling bracket, we go back up. Is 2 strictly greater than 0? Yes, it is. We go inside the while loop. Sum equals sum, which is now 7, plus cur, which is 2. So we're at 9. Cur gets decremented to 1. We hit the closing curly bracket and go back up. Is 1 strictly greater than 0? Yes, it is. Okay. Sum equals sum, which is 9, plus cur, which is 1. And cur gets decremented to 0. Again, you, the human, know that at this point we're done. The computer does not know that. It would go back up one last time. It would ask, is 0 strictly greater than 0? And the answer there is no, and then it would be done. Now, looking at kind of this unrolling of the while loop, you can kind of get lost a little bit in the details. There's a lot of variables that are being updated. Hopefully, though, there's some intuitive understanding that cur is pointing kind of at the current location. So it's 4, 3, 2, 1, and 0. So it's stepping us through the summation. And then basically what we're doing is we're simply taking the running tally, which is stored in sum, and we're just adding on the current values. So we're adding in 4, we add in 3, we add in 2, we add in 1, and we're all done. Okay, so we could choose to count up, we could choose to count down, kind of depends upon which makes the most sense to you. Okay. Okay, last I just want to talk about a few cautions. The first is what's known as an infinite loop. An infinite loop is when your Boolean expression is never true, and that happens if you have a bug or a mistake in your code. Probably the most common mistake that people make early on is forgetting to increment whatever variable is controlling your Boolean expression. Here, if we look at our Boolean expression, n is fixed. N is some number that was passed in by the user, and that never changes. There's no code that's incrementing or decrementing it. So what's changing is cur. Cur is our measurement of progress. It starts at 1, goes to 2, 3, and 4. So if you forget this line here, if you forget to increment it, then you're not actually making any progress each iteration. Cur is always 1, and you're just adding in 1 again and again and again. In that case, the computer will do what you tell it to do. It will just do it forever, and that's known as an infinite loop. Typically in BlueJ, you'll know you have an infinite loop because you'll run it, and it seems like nothing's happening. So if you have any print statements, those aren't going to show up unless they're in the loop. And then in that case, it's just going to stream forever, printing the same thing like 1,000 times. Or the method never, like your program never finishes running. So you're just waiting for your program to finish and it never does. So that's known as an infinite loop. What it means is that your Boolean expression was always true. And what that means is inside your while loop, you were never changing or updating whatever variable or variables control that Boolean expression. So you just need to look inside your while loop and make sure that you're actually updating variables appropriately. The other caution is something I've already said twice, so I'll just say it a third time. Loops never terminate in the middle unless you make them terminate in the middle. We will see a little bit later, where are we in this semester? There is the, I'm not gonna say it. I'm not gonna say it, it doesn't matter. Okay, loops never terminate in the middle unless you make them terminate in the middle, and we're not gonna talk about how to do that because it's a little bit of bad programming practice and I don't wanna encourage it. But again, you, the human, have kind of this high level understanding of what's happening in the loop. The moment some variable changes and you, the human, are like, great, the loop's done, the computer doesn't know that. So the computer will continue executing, jump back up to the Boolean expression, and then and only then, when it's false, will it resume execution afterwards. So that's that. Okay, this was a super short lecture. Basically, the in-class problems and lab and everything is asking you to practice writing your own while loops. And so in class, we'll kind of, get in your groups and look at how well you were able to solve some of the problems. I think for while loops, one more caution maybe that I should have added is oftentimes students will confuse the if statement and the while loop. And so when you're coding, if it's not looping at all, so it's the opposite of the infinite loop, it just doesn't loop, it might be that you have an if statement instead of a while loop. Okay, that's that, and we're done.